Okay, today we'll continue with our descriptive statistics, and we're going to talk about variability, and specifically we're going to talk about range, standard deviation, and variance. So what is variability? Well, variability essentially is just a way to tell how two different scores are separate or different from each other. We can compare these to each other as individual numbers, or we can compare these to the mean. We may get a set that you see here, 764,331, and we may want to know how different each one of those numbers are from each other, and also from the mean or the group. How different is the score of 4 to this total group? So remember, when we talk about average, we could be referring to mean, median, or mode. And when we get into variability, again, we have our three main areas. It's range, standard deviation, and variance. Now the range, and again, you've probably heard this before, but it's the most general term, and it basically tells us how far the highest and the lowest scores are within a group. So we basically take the highest number found in a data set and subtract the lowest number in the data set, and that gives us an answer. So if we have a data set that includes the following series of numbers, the range is going to be calculated as 7, because that's our highest number. 2 is our lowest number, so our range here is 5. Now the range of 5, that's kind of high, so you may look at this and say, wow, there may be an outlier there, and if we were to go through and look at that data set, the number 7 kind of is out of range big time there. So again, that a large range could be an indication that maybe you need to narrow down your data set, or you got some outliers that need to be eliminated. So kind of what does this tell us? Well, it's a good indicator of general variability. So again, if you have a large range, you have issues. I have gone and spoke on concussion quite a bit, and the CDC puts out a statistics that says anywhere from 2 and 5 million concussions are reported each year. Well, the range is 3 million. And so if you're wanting to know how many concussions are actually reported, and there's a discrepancy of 3 million, that's a pretty big range. So is that statistic a very valuable statistic? No. I mean, in the grand scheme of things, we use that number because it's such a large number. If I say there's anywhere from 2 to 5 million reported, all you hear is the million. And so people kind of use that to cover up what may or may not be telling you the truth there. The range is going to matter, again, when we're talking about there are between, right now on your screen it says 200 to 5,000 cases of food poisoning are reported each year. Well, that doesn't mean anything to you. But if I said that there were between 200 and 225 murders in Johnston City every December, well, that would mean something, because that's a pretty good number there. Those are pretty close compared to 200 and 5,000. Now, standard deviation. Standard deviation we will use as we move forward for various calculations, but right now, kind of getting into dusting off the cobwebs, remembering what that is. It's basically the average amount of variability in a set of scores. The average distance from the mean, and the larger the standard deviation, the larger the average distance each data point is from the mean. This is going to become very important later on. We're going to get to that, I promise. This is the one area where it's going to be very, very, very sensitive to these outlier scores I keep talking about. And we're going to see an example of that in just a moment. Using the standard deviation allows us to compare data sets when the means and the standard deviation are different. So if we look at the actual calculation, the standard deviation is the square root of the sum of the score minus the average, remember x bar is the average, squared, divided by n minus 1. Now, I don't think any of us want to take our calculator and pen and paper and calculate this out. So I will tell you that Excel, SPSS, Minitab, all of those programs will compute standard deviation for you very easily. And I'm going to provide you some examples of how to do that. Most of you have Microsoft Office. You can use the Excel function tool. It's very easy, very easy. If you are fortunate enough to have SPSS, that's very easy as well. So let's look at an example. And so we're going to look at the results from a wing contest. And so there's a lot of things on this slide. I want to go over each thing kind of individual. So if we start on the left, in a wing contest, there's 10 competitors. Their total wings eaten were placed in a graph. And so if we look in the very center, we have the wings eaten and the numbers. And so then let's look there on the left at the graph. And so on the bottom, you have number of contestants. And on the left, you're going to have the total number of wings eaten. Well, we can kind of look there, and this scatter is pretty normal. But then we look and see that there's one guy or one girl who ate 47 wings. Well, that 47 was a whole lot more than everybody else. And so clearly you can see that whoever ate 47 wings was the winner. And so from a descriptive statistics standpoint, the box on the bottom right gives us with the outlier information, because that 47 is a bit of an outlier. Our average wings eaten were 26.4. Well, how many people, if we just look at that 26.4, how many people ate 26 or more wings? There's only one. So here we take the average, and yet no one in the data set outside the winner ate 26 wings. So right off the bat, you can see how an outlier can skew your data. From a median standpoint, 24. Okay, that's our midpoint, remember from the last time. So if we look on here, we've got 1, 2, 3, 4, 5, 6. 6 people out of 10 ate 24 wings. So that's pretty good representation. And again, the range here, 24. So we look at 47 minus 23. It's going to give you 24. It's a big number. Should be a telltale sign that, hey, something's going on here. And then if we look at our standard deviation, so that means our distance from each data point to the mean is going to be 7.26. So those right off the bat, you should have kind of red flag popped up when we looked at the mean, that something wasn't right. And that is exactly how outliers can skew your data. And it's the importance of being able to look at outliers and understand how they're affecting your statistics. And so if we were to just throw that score out, if we said, okay, the person who won, we're going to throw that person out, and we're going to look at everything else. Look at how the numbers change. Now the mean goes from 26.4 to 24.11. So now we're almost right in with what the median is, because the median is still 24. The mode is still 24. Look at the range. The range went from 24 to 2. Right off the bat, again, red flag pops up. Hey, this is getting a little bit better. And then we look at our standard deviation, and it's only 0.60. So that means that the competitors were very close to each other. And the truth is, outside the winner, all of those competitors were plus or minus 1 wing. Okay, if we look at the standard deviation, they're plus or minus 7 wings, which that's not really a true representation of the whole group. So when you look at data, and when you start to interpret things, and you start to look at a data set, or if someone just tells you, well, the average is 26.4, and then you start looking at the competitors' scores, and you say, wow, something's not right here. Look for those outlier data. An easy way to do this is to do a visual representation, because you may miss it. You may look at a series of 200 numbers, and you may miss it. But you know what? If you do a scatter plot graph, just like the one here on the bottom left, those outliers are going to stand out. And they're going to stand out because they're going to be way out of kind of the norm there. Now let's talk about variation. Okay, variation basically is the standard deviation squared. And so variance equals standard deviation squared. And you're probably not going to see this listed a lot of places. We may have some statistical calculations where we actually use the variance. But if we didn't want to use the variance, we would just say we're using the square root of the standard deviation. So if we look at it, this is essentially it, standard deviation squared, or we just take the square root of the standard deviation. So if we look at a group of production workers who are on average assembling circuit boards at an average of 8.6 boards per hour, and has a standard deviation of 1.5. Well, the standard deviation of 1.5, that's the difference in the average number of boards assembled per hour from the mean. Well, if we were to look at the variance at 2.53, that really doesn't tell us anything. It doesn't make a whole lot of sense. And so alone, it's very hard to kind of make some sense out of some of these numbers. The value of these will become more clear as we get further down the road. Now, these are very basic kind of descriptive statistics things, but you're going to see all this represented in research articles. You're going to want to calculate these basic descriptive statistics for your own research. They make it's very, very helpful. For those of you who are looking to find needles in a haystack, well, these outliers are important to you. For those of you who are trying to make sense and make decisions, you're not going to want to include these outliers because they're going to mess up your data. And in your homework for this section, you're going to see that. And I want you to use that homework to help make a good decision, which hopefully will help you down the road when you are having to make decisions to use the correct method of determining whether you should use the mean or the median. Again, if you have questions, please let me know. Again, we're taking this kind of bite by bite through some of this quantitative stuff. We'll get to it. We're getting ready to get into correlations. What is it? How do you calculate correlations? We're going to be using a lot of Microsoft Excel. If you don't have Excel, please let me know. But there'll be the examples that are online. You can find these on YouTube. You can find examples and help of how to calculate all of the descriptive statistics along with the correlations that we're going to do next time. So again, if you have questions, let me know. Thank you very much.